Oh, so you have written in the chat box. Negative. Yeah, so that part we missed in this question, right? So in this 45th question, because the pendulum was moving upwards, right? And if you check the notes, so the answer that we got was 4 meter per second. But it cannot be because whenever we are going upwards, so the velocity cannot increase. So the work done, this there was a minus sign that we missed, and please correct that. So all of these rest of the people were there, and they have corrected, but you should correct this thing also, right? So this was the correction that I wanted to point out, right? And only whenever you know the potential energy, right? So then from there you can always calculate the work done. So the negative of potential energy is the work done, right? So whenever we have a confusion, just remember the potential energy, take the negative of that. So that would be the work done. Okay, so now we are studying this AC, and yeah, it is going to be iftar time, so I'll be back in 3 minutes. In the meanwhile, you guys can do what is the question, right? So you guys can try this question. Try this question, and whatever the answer you guys get, please tell me, right? This is the question that you guys should try. Yeah, please try this question and tell me the answer that you guys are. And today I'm planning to finish this EMI also, not EMI, but electromagnetic waves. So that will, yeah. So please try this question. Okay, I'll be back in 3 to 4 minutes. Just try this question. So you have an AC circuit, right? And you have to find out the power factor. So ratio of the new power factor with the old power. Please try this one and then I'll be back. Okay, yes. So I have only got one answer from Maria, right? Maria is saying that the answer is, yeah. So Maria is saying that the answer is ratio is one, 1/1. Oh, so X is one. Yes, rest of the paper. What do you guys think? What is the answer? Yes. What should be the answer, guys? The first time they have added, right? In the case first, they have added resistance with the inductor, right? This is what they have added, and this is R. This is 3R. But this is a series combination, and they have different phases, right? So this would not be 3R plus R because they have a different phase. So the resistance, effective resistance is right. What is the effective resistance? So that is represented by Z, and this is R square plus whatever XL square, right? And in the second case, right, so this is R square plus what is this thing? 9R square. So this is root 10 R square. So R square or R root 10. So this is the first impedance. And from impedance, we can calculate the power factor. So power factor is cos phi. This is R by Z that we have just studied in the previous class, right? So all these things we have studied. Impedance or what was the R? So power factor was R by Z. And then, right, so what would be the power factor? This is R by root 10 R, so 1 by 10. This is the case first. In case second, we will write directly. So that is R square plus 2R square. Right. So then what do we have? We have Z, which is this is 3R square. So this is R root 3. Right. So then, okay, now a capacitor is added in series such that XC is 2R. So they have not written that whether the inductor and the capacitor they are added same, right? So what is this thing? Power factor is new power factor that is R by Z. So this is R by R root 3, right? So this is 1 by root. So we are getting, right, what we are getting. So this is ratio of new power factor. So that is 1 by root 3 divided by old power factor. That is 1 by root 10. So how much is this thing? So this is root 10 by, okay, so I guess they are saying that this capacitor is added along with the inductor, right? I guess they are saying that. So let's wait in that. Right. So they are adding more of this capacitor in this side. So then the impedance would be XC minus XL whole square. So then what do we have? This is R square. XC is 2R minus 3R square. So what do we have? We have R square plus R square. So this is root 2 R square or R. So this is the impedance, root 2R. And then if we calculate the power factor, So that is R by Z. So this would be R by root 2R. So that is 1 by root. So this is the new impedance and this is the old impedance, right? So as Maria has got, right? So the new one is, let's say, power factor new, which is 2 divided power factor 1. So this is 1 by root 2 divided by 1 by root 10. So this is root 10 by 2. So root 5 by 1. So that is what Maria has got, right? And what about rest of you guys? What happened? So is this thing clear, right? Is it clear?
Yes, sir.
The important thing is that the capacitor is added along with the. So this question is somewhat unclear, right? This question is somewhat unclear whether they have removed the inductor and then they are adding, or this is added along with the inductor. So if it is added along with the inductor, then this would be the answer. If the inductor is removed and the capacitor is added, then we would have a different answer, right? So then you guys have to check. Oh, so this was the integer question, right? Then yeah, so then this should be because they are not saying that they have removed this inductor and they are there and then they are adding. So we have to assume that this inductor is also there. That is why we have this XL also. Yes, clear everyone? Yeah. So then let's move on to the or yeah, you guys please note this thing down. Quickly note it down, and then we'll see the next question. So all these questions are based on the LCR circuit, right? And we know everything about the LCR circuit. And now after that, I will talk about the charging and discharging and growth and decay of the current. So that we will talk. Okay, yes, quickly, did you guys note it down? Yes, noted everyone?
Yes, sir.
Okay, okay. So what is it's a different question, and then we will come back to this question. Uh, and there is also this important question which is there that I have not. We bring that, and then we'll discuss that, and then it will become. Okay, so first let us do this question. Right, this is the question that we have. So we know that whenever they give you this, oh, this is also not. Yeah, I will bring the option in here. So let's say we have this question, and option we can check, right? So this is the question. And if we look at the question, right? So can you guys tell me that because can we use the junction rule? Can we use the junction rule in here? So we have this current, right, and this current. These are two different currents. Let's say this is I1, this is I2. So can we use I equals to I1 plus I2 in here? Can we use the junction rule? Yes. What do you guys think? Can we use the junction rule? Yeah. Can we use this thing in this situation? Any guesses? Yes or no? So this answer is binary, right? The answer is binary. Yes or no? Zero or one. So can we use this junction rule in here, this situation, in this diagram? Can we use junction rule? Guys, are you guys there? Yes or no? You can also write if you are guys are hesitating to answer in the microphone, so you guys can write it in the chat box. Can we use this junction rule? Yes? Anybody? Okay, so I guess everybody is silent, exhausted. So we cannot use this thing because the currents, right? Current flowing in this one and current flowing in this one, I1 and I2, they are not in same phase. Just like the LCR circuit. So we had this LCR circuit, right? Let's say we had this LCR circuit. In the LCR circuit, we had different voltages, right? V1, V2, and V3, or specifically VL, VC, and VR. But we didn't write the total voltage as V1 plus V2 plus V3 because they were in series. So we didn't write this thing. Why? Because the phase was not seen, right? Phases were different. Similarly, similarly, whenever we have this parallel connection, and we cannot simply add these currents. So if we want to add these currents, then we have to use this phasor, right? So then we have to apply the phasor diagram. Okay, so let's do this question. So first we have to find out, right? We know that we cannot add I1 and I2. First we have to find out what is what is I1 and what is I2. So this combination in series, right? That we know. And this is parallel combination. This is parallel combination. So the voltage supply in this circuit is 200. So voltage supply we know. Now we can find out the resistance in this circuit. Right, resistance in this circuit we can find out. So what would be the resistance? And that is called impedance in our case. This is simply, so this is only capacitor and resistor. So this would be XC square. Right. How much is XC? XC is 1 by omega C. Right. So omega, we already know that is 100 radian per second. Capacitance is how much? 100. And microfarad. Microfarad is 10 to the power minus 6. This goes over here, so this will become how much? So 4 power is neglected, so this is 100. Right? 100 ohms. So this is the resistance, right? XC. And let's find out this total resistance. So how much this would be? 100 square plus 100 square, let's say Z1. So this is 2 into 100 square So this is 100 root 2. Right. This is Z1. Now we can also find out the phase angle between them because we have to take care of the phases, right? So let's find out the phase. So cos phi is right, or tan phi. Tan phi is how much? Tan phi is Z, or this is XC minus XL by R. So this is simply XC by R. So this is 100 root 2 divided by R, right? So how much is this thing? R is 100 also. So this thing is cancelled and we have root 2. What is the value? Oh, this is not XC, right? So XC we have found out 100. So this is 1. Then phi would be how much? Let's say this is phi 1. So phase angle is, because this is tan phi is 1, so that would be 45 degrees. So this is the phase angle. And now let's talk about the second part. So from here we can calculate the current I1. I1 is how much? Voltage divided by this Z1, right? So this is 200 and then divided by 100 root. So how much is this thing? This is 2 and then this is root. So this is the current, and then we have this second circuit, right? Inductor and this resistor. So from there, if we calculate, let's say Z2. So to calculate the Z2, we need to calculate XL. That is omega L. So omega is 100. Inductance is how much? That is 0.5 Henry. So 0.5. So this is 50. So 50 ohm is the inductive reactance. And then if we calculate Z2, so this is root of R square plus this 50 square, right? So we have 50 square plus 50 square. So again 50 root. This is, and then we calculate the angle tan phi 2. So this is XL by R, and this is how much? Right, actually this is minus XL by R. So this would be how much? This is 50 by 50. So again 1. So we have pi 2, which is 45. But this is in the opposite direction. So this is minus 45, right? So we have this angle and we have the other angle, and then we can also calculate the current I2, which is how much? V divided by Z. So V is 200 and then we have Z2, which is 50 root. So how much is this thing? This is 4, right? And then this is 2 root. So this is the current. Now, because we have to use the phasor diagram, right, to find out the current. So we have, let's say this is the voltage and the current is leading. I1 is leading 45 degree and this one is lagging 45 degree, right? This is I2. So the angle between I1 and I2, these are two vectors. So the magnitude of I, that would be I1 square plus I2 square, right? And the angle between them is 90, so the cos 90 is 0. So if we use the vector representation, right? So the overall magnitude, that would be how much? That would be root 2 square plus 2 root 2 square. So how much is this? 2 plus 4 to the 8. So this is root 10. And how much is root 10? So root 10 is How much is root 10? Root 10, 3.1 ampere. So this would be the current. Right, this is the idea of this question. So part by part, if we do this question, then it would become clear, right? Is it clear, everyone? Is it clear, guys?
Yes, sir.
Yeah. So quickly note this one thing down, and then I'll give you guys another question to solve. So we have to apply those basic concepts, right? And there are no other concepts, extra concepts that we require to solve these kind of problems. We have to just remember that what is the LCR circuit, what is the impedance, what is the power factor, what is the phase angle and all these things, average power. So from those things we can calculate the answer, right? Okay, so yeah, whenever you guys have noted down and if you want to scroll down the screen, then please yes, noted up to this point. So if you guys have noted, just note down this part, right? Yeah, so this minus is all only representing that we are calculating the angle in the reverse direction, right? This is the anti-clockwise. If we measure the angle anti-clockwise, that is positive. If we measure the angle clockwise, that is minus. So that is the voltage, right? Okay, yes, noted everyone. Got disconnected. Oh, then who got disconnected? Yes, noted, guys. And in the option, yeah, so in the option, this was not in the option, right? So 5.9, 4.24, 0.946A. So this is not in the option, right? But this is the correct answer. So yeah, this is the correct answer, and this was not in the options. Yeah, noted everyone.
Yes, sir.
So then you guys, then we'll do one question more from here, and then we will the power dissipated at resonance, right? Okay, so this is an important question. Which question we should do? Okay, so you guys please do this 12th one, right? You have this LCR circuit. It's connected across an AC supply of 250 volt having variable frequency. The power dissipated at resonance condition is how much? So at resonance condition, how much is the power? This is the thing that you guys have to calculate. This one is a very simple question, right? Please try this one and you guys already know that what is the power dissipated, right? So power dissipated is simply VRMS, IRMS, and cos phi, right? This thing is power dissipated, and we can also write it as I square RMS and cos phi. So these things are, yeah, so this is all, right? Yeah, please tell me what is the answer that you guys are. So everything you know, right? VRMS is V naught by root 2. IRMS you guys can calculate by dividing VRMS divided by Z, right? And what is cos phi? So cos phi is R by Z. At resonance, what would be the, right? At that resonance, what happens? At resonance, what is current? What is the other thing, right? So that thing we have. The voltage VRMS. Yeah, whenever they give you this AC supply, right? So this is 250 volt is not VRMS, right? That is the peak voltage, right? So just you saw in this example, right? So you saw that this 200 volt was not the RMS value. So this was the peak voltage. But yeah, so this is the peak voltage. But yeah, if I remember correctly, so whenever they give, so this is generally the RMS value, right? In NCRT problems, whenever they give all these voltage, so they give only in the RMS value. So yes, this is RMS. Yes, Maria, yes. This is RMS, not the peak one. So this is RMS. So in the household supply also, the 220 volt that you get, so that is the RMS value, right? All these are RMS values. Okay, somebody has already got the answer. So Maria is saying 125. Right. What do you guys, so please do, or rest of the people, please also this question and tell me what is the answer that you guys are getting. Yes, guys, what is happening? You have to find out the resonance condition. So yes, Maria, I have checked, and whenever they give you all these values, so they are all the RMS values, right? We have to always remember that whenever they give AC supply, so all these values are RMS values. But if they give you something like that, 300 sine omega t, so then you know that this is the peak voltage, right? But if they don't give you the form, then in every if they just give you these values, so they are the RMS values. Yes. What about rest of you guys? What did you guys get? We have already discussed what is the resonant condition, right? So we have discussed that at resonance condition, this value becomes equal. So your impedance is simply the resistance, right? So if you put that back in here, what you will get? So if you put that back in here, so Z is R, right? Means that cos phi is R by R, that is 1, right? What is your power? So VRMS, IRMS, you don't know, then you can calculate because power is, or we know that, VRMS is IRMS Z, so we can put that value in here. So this is VRMS and Z, which is R. So this is simply V square by R. So how much is this thing? 250 into 250 divided by R, which is 5. So this is 50. So this is 12500. Right. So 125 into 10 to the power square watt. So this would be the answer. Right. This would be the answer, guys. Why didn't you guys? So just remember the conditions, right? This is the only formula that we have to use. And these are the rest thing that we all know already. So, okay, is it clear, everyone? Is it clear? Yes, Maya, your answer is correct. So, is it clear, everyone? Oh, who is getting disconnected? I guess, oh, so I guess Madhya is getting disconnected. Yes, Madhya, what is happening with your internet? Okay, so now these are, I guess these question you can do easily, right? So 30 milliampere Henry, inductance is given, resistance is given, to an AC source, frequency is also given. The value of capacitance for which the current leads the voltage by 45 degree is right. So you have to find out the value of capacitance C, which you have to find out for which the right. So what is you have to find tan phi for which XC minus XL, right, by R. So this is tan 45 is 1. So this thing you have to find out, right? And yeah, you know all these things. So the thing you can see. So I will leave this question to you, and rest of the question, I guess, from LCR circuit you can do, right? And somebody was saying that I have to share this one note. So what I will do is that I will share, yeah, the link of this notebook in the chat box, and then you guys can write. So okay, let me share this web page. So I have shared the OneNote with all of you guys, right, in the chat box. And yeah, you guys can practice some of the questions from here. And remember, so I guess Tariq's exam is on 5th of April, and so you guys have your exams in later late dates. But the aim or the goal is to solve 8 questions, right? Just remember this thing only. So tomorrow I will try to complete. Oh, Maria, you have also your exam on 5th. Yeah, okay, good. So, yeah, so then also, more I will try to complete ray optics and wave, and then these would be enough to solve 8 to 10 questions, right? Don't extend. I have just talked about these things so many times. Just follow these notes. I have shared the link, right, in the chat box with all of you. So, did you guys get the link for this one? I have shared with everyone. So just check your chat box, and I have shared, right? Okay, so yeah, 8 questions. No, sir, like a link. Oh, link. What is, how do I see? Notebook color copy link to notebook. This is the link that I have shared, right? What should I share? Let's say share. Oh, can edit. Okay, so then you guys have to share your email address, right? Okay, so I will, yeah, I will share this with Learnivio team, and then they will share it, right? Because I guess you guys have some difficulties in opening that one. So I will share the link in the email. Okay, is that okay with you? Send a copy. Send a copy. What- Yeah, so I will share in the email. Okay, Tariq. So I will share it in your. I will share it with Learnivio, and then they will share it. Okay, kit. And then you have this RL circuit. So derivation, again, derivation is not important. I will not talk about this thing, the end result, right? So we have this RC circuit. This is connected with, is there LCR in parallel? No, no, we don't have any LCR circuit in parallel, right? So we don't have LCR circuit in parallel. But remember what will happen. Whenever we have LCR circuit in parallel, so then your voltage is same, right? Voltages are same, and then you have right, and then you have this current. So then you have to talk about the phase diagram of the currents. So you make the phase diagram of the currents, and then you obtain the result. So then you see what happens, right? So then you have to, yeah, the LCR circuit in parallel you don't have, right? What did we do in series? ask this question. Yes, Iyad, you have asked. Iyad has asked that do we have LCR in parallel? So we can check that. But yeah, this is not in your syllabus or not in JEE. But we have done one question based on that, right? But you have to only remember, yeah. So this was not the LCR circuit, right? This is only the two currents and they are in parallel, right? So, but if you have LCR circuit in parallel, then I will just tell you that what will happen, right? So you have made this phase diagram, right? You have made this phase diagram using the voltages. So you said that you had this current, right? You had this current and all these things were with different phases, right? So resistive circuit was in the same phase. Then inductive and capacitive circuit was right. So this inductive circuit was this current was lagging behind, right? The current was lagging behind for inductive circuit, and for capacitive circuit the current was leading. That we have understood. So you will have a different diagram there, right? Then you will have to make right. So then you will have to make a voltage, which is something like that. Let's say you have this voltage. So this is the supply, V naught omega t, sine omega t. So this is the supply voltage that you have. And let's say your voltage, right? So in the resistive voltage, the voltage would be VR, and this would be same as right. So this IR would be same, and then you have to right. So then you have to think that what is so if you have this voltage, then in inductive circuit, the current is lagging. So this would be the inductive circuit, and this would be the capacitive circuit, right? And then you make the phasor diagram. So your I, the net effective I, that would be how much? So then you have to calculate. That would be something like IR square plus IC minus IL square, something like that. And then this I is V naught by Z. So you will get something like, one by Z, one by R square plus this would be, yeah, one by XC square minus one by XL whole square. So something like this you will get, right? So this would be the result. But yeah, this is not in the syllabus, so this has a different. So yeah, this is not needed. Okay, but yeah, the important thing that we need is this RC circuit. So you have this RC circuit, and you don't have, in this case, you have to remember that in RC circuit, you don't have this AC supply. In RC circuit, you will have this DC supply. Then you write this equation, and you will get a linear differential equation that you guys have learned. Right, so this is a linear differential equation. You calculate the integrating factor and then you derive. And then the end result of RC circuit is this. So please note down this thing only. So you do all these initial conditions and then you will get this thing, right? Okay. So this is the thing that you will get. In RC circuit, just note down these parts. So just note down this. This is the end result. No need to derive all these relations. So in charging state, this is your charge which is increasing, current is decreasing. So the charge is increasing like this, right? And then current is decreasing like this. So this is your RC circuit. Okay. And in this discharging state, the charge is decreasing like this. And remember, this RC is also called tau. So your charge is written as Q E minus T by tau. Why this is called tau? Because this has a dimension of time. So this is the just note down these parts. Only this much we will need. Yes, note it. Whenever you guys have noted this part, just tell. Yeah, and this thing guys have already learned that this is called the saturation point, or this is also called the steady current. So or steady state, right? Because your current has become constant. So note it down this part. Did you guys note down this part? Okay, I guess you guys have noted. So this is what happens in RC circuit. And then you have this RL circuit. So you saw that in RC circuit, the charge was increasing, but in RL circuit, the current will increase, right? So it will increase like this. So this is RL circuit. Just remember this. This is the RL circuit, and this happens in the RL circuit. So your current is increasing like this. But the important thing is that in this case, tau is different. Tau is L by R, right? So your tau is L by R in this case. So you have to remember that taus are different. In RL circuit, this is the tau, and in RC circuit, the RC is your tau. Yes. If you guys have noted, then we'll do some question based on this. Noted, everyone. Yeah. So then let's talk about some questions. Let's much wrong with this question. So whose internet is fluctuating? Somebody is getting disconnected again. Yeah, I guess this value would be important, right? So you have this circuit. So this is an open circuit, but when this is closed, so this capacitor goes in the charging state, right? The time taken for the capacitor to be charged to get 50 volt. So we have to find out what is the voltage at which this becomes 50 volt. So voltage is given, right? We know how this charge is right related with the time. So how this is charged? We know that this relation is or we have Q. This is the variable Q. This is the maximum Q, and then this is related as 1 minus E T by R. So we have to find out this time at which the time at which this becomes 50 volt, right? So let's calculate this thing. So we know that if we divide it by C, right? If we divide it by C, so this will become how much? So Q by C, that is V, and this is V naught, and 1 minus E minus T by R. So this is how the voltage is changing. Voltage is increasing, right? So the maximum voltage is how much? That is 100 volt, right? So the maximum voltage is 100, and we have to find out the voltage at which this becomes 50. So this variable one is 50, this one is 100, and 1 minus E minus T by R, right? So then if we take this thing in the left hand side, this is 50 by 100, right? And this is 1 minus E T by RC. So then this is 1 by 2, and 1 minus E minus T by RC. So this thing goes in the left hand side, and this thing goes in the right hand side. So what we will have? We will have E minus T by RC, that is 1 minus half, so that is half, right? This is power negative. So if we take it, right, if we take the positive power, so this would be ET by RC. We just take the reciprocal. So this would be 2, right? And the idea is that we have to find out this time. So we'll take the log in both these sides. So T by RC, or let me write it as ln, right? Because we are taking log E power, log to the base E. So we'll take ln, and this is E to the power T by RC. And then this is ln 2. So how much is this thing? So this becomes power is down. So T by RC, and then ln E. Ln E is 1, right? This is ln 2. So we have T, which is RC, and ln 2. So how much is this value? How much is ln 2? So ln 2 is 2.303 log 2, right? And what was log 2? So let's find out this value you have to remember, right? But this would be crucial. So let me just find out this thing, but you guys have to remember this, right? So 2 ln. So ln 2 is 0.69314. So you guys have to remember this thing. This is 0.69, right? Okay. Value is given in the question. Oh, yes. So I missed that. So yeah. Or if it is not given, but you just remember that what is ln 2, right? This would be really helpful. So if they don't give you the value, then you can't use the calculator as I just used. So just remember that ln 2, remember, ln 2 is 0.69. Log 2 is different. So ln 2 would be 2.303 log 2. So this is 2.303 into 0.69. So how much is that? Something 1 point something. Yeah, this is different. So you guys have to remember that ln 2 is simply 0.69. And yeah, so as Maria pointed out that it was given, so we can use this thing also. Okay, so we have got ln 2 is 0.69. So let's keep it this value. R is given. What was R? R is 100, C is 1 microfarad. So R is 100, C is 1 micro, which is, and then we have 0.69. So 10 to the power 2 minus 6, so this is 10 to the power minus 4. So this would be the time at which the voltage becomes 50 volt. So this was a direct question, but yeah, there was some minor calculation, right? Noting down. And if you guys have any doubt in this question, please tell me. So the only thing that you guys have to remember you have to remember that what is the charge. So this is Q, this point is Q max or Q naught. So you have to remember this in RC set. Okay, just quickly note this thing down. And who is getting disconnected? So this time Madhya is also here, Tarif is also here. So Shahid got disconnected and Fadil got disconnected. I will share this one note with you guys in your email, right? So you guys have provided the emails to the Learnivio account, right? So I will share this. And the link that I have shared. So what is happening with the link that I have shared? Is there something happening in the link, or is there some problem with the link? Yes, Tarif. In the chat box, the link that I have shared, is there any problem with that? Yes, Tarif. So you said that you faced some problem, right? Can you tell me? But okay, yes. Quickly, you guys note it down, right? Please note it down, and then we'll do the next question. And I will also start electromagnetic waves. Yes, Tarif, you are saying something. Oh God, so your voice is disruptive. So okay, it's breaking a lot. So I cannot hear you properly. Anybody else can hear Tarif properly? Can you guys hear Tarif properly? Okay, so what is that? I don't know what is that? Because your voice was breaking a lot. Yes, everybody, note it. We will do two questions, not two questions, one question more, and then yeah, and then we will talk about transformers. So let me see another question that I can find out. I have solved this one. Yeah, this one was direct, so I will just explain it, right? So you have an RC circuit, and they want you to, so this is the AC source with which it is connected. So you have the charging state, discharging state, charging state, discharging state. So then the output would be this charging, discharging. So from here to here, charging, then discharging, charging, discharging, charging, discharging. So this would be the answer. See, so I will not discuss this question, yeah, in detail, but you just that this would be the answer. Okay, so now, yeah, let's do this question. And this is RL circuit, right? So let me quickly. Okay, yeah, somebody else. Okay, yes. So yeah, so let's do this question. And I forgot to tell you that what is the energy is stored in the inductor, right? That thing I have talked about, right? I guess I have talked about that. If I have not talked about that, then I guess I have talked about the energy stored in the inductor, right? So that I have talked. Yes, power. And what about the energy? Energy? Did I miss energy? Okay, so yeah, just remember also that oh, in EMI we have talked about the energy of the inductor, right? So this thing we have talked about energy of the inductor. In EMI we have talked about. So this is the EMF generated in the inductor, and then this is the energy. So that thing we have talked about already. So let's then this question would be easier to solve. So we have an RL circuit, right, or LR circuit, and they have given. I will do this question very quickly, one question, and then we will move on to transformers. These parts I will not do right that much of time. So you guys can practice some of the question. They are too direct, right? So if we just know the basic concepts, then these questions would be simpler, right? And the goal is only 8 questions. So I guess if you just do these things, then the goal, we can achieve the goal, right? Only remember, if we remember the basic concepts, then applying those things would be easy. So we have this RL circuit, right? We know that how the current increases in the RL circuit. That is I naught and 1 minus E RT by L, right? This was the current in the inductive circuit, and we have to find out if the circuit is switched on at t equals to 0, then the time at which the energy stored in the inductor reaches 1 by n times the maximum value. So we know that what is the energy stored in the inductor, that is half Li square, right? And the maximum energy. What would be the maximum energy? This is a constant thing. Only I is changing, and maximum I is I naught. So this would be half Li naught square. This is maximum, and we have to find out the time, right? We have to find out the time at which the energy stored becomes 1 by n times the maximum value. So the time at which the energy stored, let's say ut, this becomes the 1 by n times u max. So this is, and from here we have to find out this t. This is what they are saying in this question, right? So let's quickly write down this thing. Ut is simply this one, which is half Li square, and this is equal to 1 by n times half Li naught square. L cancel, two cancels, and we have simply I square, that is I naught square divided by n. So we can simply write I is I naught by root n, right? So then what do we have? I is I naught and 1 minus E RT by L, and this is I naught by root. So I naught again cancels, and what do we have? We have 1 minus E minus RT by L, and that is 1 by root n, right? And we have to find out this T. This is the goal. So again, we'll do the same thing. We'll take this thing the right hand side, take this thing in the left hand side. So RT by L, this is 1 minus root n. So what is this thing? This is RT by L, and this is root n minus 1 divided by root. Oh, this was minus, right? So now, because this is negative, so we have to take the reciprocal. We take the reciprocal, this becomes RT by L, and this is root n divided by root n minus, not the long one. So root n minus 1. And then we'll take the log. So this is, I will directly write, this is ln root n divided by root n minus 1. So t is how much? This is simply L by R ln root n divided by root n minus. So this is the time at which energy becomes 1 by n times the maximum. So L by R root N by root N minus 1. Oh, hmm, what is the correct option? N by root N minus 1. So this one, right? I thought that I had ticked this one. So this is the correct answer, right? Is it clear, guys? Yes, if it is clear, quickly note it down. And what was the idea? We had to only remember that in RL circuit and in RC circuit, what is the charging and discharging state, right? So, or what was the increasing growth of the current? Oh yes, sorry. So yes, note it down, guys, and then we will do the next question. So then I will talk about transformer, and then uh, we will talk about electromagnetic waves. Tomorrow I will start ray optics and wave optics, and hope I will just quick. I will give a quick glance of the topics that you have covered, right? And I will also talk about because when you guys joined, so you guys told me to talk about the gates, logic gates, right? So we talked about uh, AND gate, right? So you guys told me to talk about OR and not, NOR, NAND, and what is the? Do you guys have this XOR gate? I guess you don't have this XOR gate, right? So you guys have only these five gates, OR, and these are quite simple, right? So these are quite simple. They will take only 15 minutes to talk. So these things we can just. So tomorrow I will try to talk about these. So this is and this is not right, or this has only one input. So this has. Sir, one doubt regarding the eight question. Should we do eight question in total or eight MCQ and the five compulsory numerical types? Eight question as a whole, right? Eight question as a whole. So the compulsory integer that you have to solve, right? The compulsory integer that you have to solve is from all the subjects: physics, chemistry, math. You have to combine all this thing and then you have to solve five compulsory integer topics, right? So first you complete this thing. You first complete this bare minimum, and then yeah. So let's say you find some question in chemistry only that has that you can do the integer type. So let's say you find three questions from here. Let's say you find two questions from. So then you don't need to do any integer type from here. But we have also solved some integer type questions from the previous chapters, right? So you can also do two questions from integer type that you can do, and then rest six you can yeah solve the MCQ. So yes, you just figure it out. But the end goal is to complete eight questions, right? If you can complete this thing, remember no negative marking. Don't guess until and unless you get a perfect answer. Then only you just write that down. Otherwise, don't. And then we have this NOR gate, right? So what is this NOR gate? We'll talk about this thing tomorrow if we have time. So this NOR gate is this, right? So NOR gate is simply OR gate plus this NOT gate. So in OR you just add this NOT, and then we have this NAND gate. So these things, yeah, these are quite simple. This will take only 10 to 15. So you have to make those. What are those diagram called? Truth table. Yeah. So those are called truth table. So you have A, B, and then X. So this is 0, 0, 0, 1, 1, 0, 1, 1. Because you have this OR gate, so OR is plus. Just remember OR is plus and is multiplication. So 0 plus 0 is 0, 0 plus 1 is 1, 1 0 1, 1 1 is 1. So this, whenever you get this kind of combination, then this is called the output. Whenever you get 0 1 1 output, so that is your OR gate. Whenever you get this kind of output, right? So whenever you have A, B, and X, 0 0 0 1 1 0 1 1, and is multiplication. So 0 0 is 0, 0 1 is 0, 1 0 is 0, and 1 1 is 1. So this is your AND gate. This is the truth table for AND gate. And then NOT gate. So NOT gate is simply A and X. So if you apply 0, so this would be 1. If you apply 1, this would be 0. Opposite to that. And yeah, so okay, so we'll talk about this thing in tomorrow's class, right? If we have some time. So because this will not take that much of time. I just diverted from the original topic, but did you guys just note down this part? Have you guys noted down this part? Yes. Did you guys note down this part?
Yes, sir.
Okay, so then let's talk about transformer. Then this chapter would be over, and then we will quickly in 15 minutes we'll try to talk about EM waves, right? Or okay. So in transformers, you have to remember that we have two coils, right? We have primary coil, we have secondary coil. These are the parameters for primary coil. These are the parameters for secondary coil, right? But in transformer, we assume one important thing. What is that important thing that we assume? We assume that the total power is so whatever power is in the so the total power is transferred in the secondary coil. That is the thing that we assume. But most of the cases that is not there because we have some power loss, right? Because whole the area is sometimes the whole area is not because this area can be different. So we can have some power losses as well, right? And we have those eddy currents also. So we have some power losses also. So in that case, we use the idea of efficiency, right? So remember that we have this primary parameters, then we have the secondary parameter. And we have to remember that if we have 100% efficient transformer, right? So that thing I have already written in here. So if we have this thing is always the case, right? Your voltage in primary that would be ratio would be just ratio of these number of terms, right? So you have to remember that by changing the number of turns in the primary and secondary coil, we can manipulate the voltages, right? We can manipulate the voltages. So if we have this number of secondary coil, number of turns in the secondary coil that is greater, right? So NS is greater, then what will happen? NS is greater, this quantity is greater than 1. So Vs, so we can increase the voltage in the secondary coil. So if we can increase the voltage in the secondary coil, let's say you are applying a 200 volt of voltage in the primary coil, and then you are getting a 400 voltage in the secondary coil. So then you have increased your voltage, right? And how did you increase that? By just changing the number of turns. So you increase the number of turns, then voltage increases. So that is the step-up transformer, and you have this step-down transformer, right? So in step-down transformer, the secondary number of turns in the secondary coil is less, so voltage is less in the secondary coil. That is called the step-down transformer. And what I was talking about is that 100% efficient transformer. So the power is same. So then the ratio of the voltage is equal to the ratio of the current. So if you have a step-up transformer, then the current will decrease, voltage will increase. So that is the idea of the step-up transformer. Voltage increases, current decreases. Similarly, if you have a step down, so voltage decreases, current increases. So this thing you have to remember. But if we have a power loss, then we have the efficiency, which is power output by power input. So this thing you have to remember. If you remember this thing, then all the questions would be easy to solve, right? So just note down this thing. Just note down this thing and also note down this, right? That you have this relation that voltage, right? This thing is how much? This is equal to ns by. So this thing you have to remember. So if you increase ns, right? If you increase ns, this is greater than 1, then Vs is greater than V. So step up and then Vs is less than Vp, step down. So this thing you have to remember, right? Just note down this. Okay, yes. Whenever you guys have noted, please tell. Just remember this thing, right? So if you remember this thing, and these are easy peasy questions, right? You will get full marks just remembering this thing. So you have to remember that what are the parameters of primary coil, what are the parameters of secondary coil, how they are related, and if the power is not, or if the transformer is not 100% efficient, then what is the efficiency? This is the thing that you have to remember. Okay, if you guys have noted, oh, done. Okay, if you guys have noted, so let me just already. And whenever they have not mentioned that there is a power loss, then you just assume that that is a 100% efficient transformer, right? So yeah, whenever they have not mentioned that it is a, right, what kind of transformer is that? So just assume that that is a 100% efficient transformer. So what is the voltage in the primary circuit that you have? This is the primary one. So VP is 220. IP we don't know, right? And then we have this, okay, and then we have this IS, which is 0.11 ampere. And then we have, okay, then we don't know what is V2. So load is given, right? Or power is given, which is 60 watt. So we can simply calculate what is IS we know, PS we know, VS we can calculate. What is VS? VS is simply 60 by 0.11, right? Okay, because we know that PS is VS IS, so VS is PS by I. So how much is this thing? This would be, let's say, 6,000. So how much is this thing? 200, right? So what kind of transformer is this? You see, this was such an easy question. What kind of transformer is this? Yes, what kind of transformer is this? You have increased the voltage. Oh, so everybody, everybody has disconnected. So yes, Maria, what we will do is that because everybody has disconnected. Oh, Tarif has joined back. Yes, guys, Maria and Tarif, what do you guys think? What kind of transformer is this? So this is the step-up transformer, right? Voltage has increased, so this is a step-up transformer. Yeah, then let's move on to an efficiency type question, right? So let's see if we have 300 turns, then output voltage. So you see that these are very simple questions, right? You will find very simple questions. You have to just remember what are the parameters for input one, what are the parameters for output one. You just write them side by side, and then this becomes very easy, right? So let me just write it in here. So a transformer consisting of 300 terms, NP is given 300, NS is given 150, right? So we know that NS is less than NP, which means that this is a step down transform, right? That thing we already know. Okay, so gives output power. Power secondary, that is 2.2 kilowatts, so this is 2200 watts. If the current in the secondary coil IS is given, that is 10 amperes, then the input voltage and current in the primary coil. So we have to find out we have to find out input voltage, IP we have to find out, and input voltage we have to find, right? So this is the idea. What do we know already? What is the thing that we know already? We can calculate the voltage in here, right? So voltage of secondary coil is 220 by 10. So this is 220 volt. Vs we know. Now we know the relation between Vs, NP, and all the other things, right? So we know that power input, we know that simply NP by NS and Vs. NP is 300, NS is 150, Vs is 220. So this is 2. So this is 440 volt, right? We already know that this was a step down transform. VP we know. So we know that power is same. So PP is also same. PP is 2200. PP is 2200. So we can find out IP. That would be PP by VP. So what is this thing? This is 2200 by 440. So this cancels 22. This is 10, right? So this is 10 and this is 5. So IP is 5 amperes, right? This was the question. So you'll get easy questions from this transformer, right? They will be too direct. Only thing that you have to remember all these things, right? So we'll stop here, right? I wanted to this thing we I wanted to do, but you guys can try this one, right? So just you guys try this one. This would be very easy to understand. The efficiency, and then efficiency you can relate with powers. You relate it with power, and then you one thing would be unknown, and then you can calculate. So these are very easy questions, right? So I will stop here, and I will share this OneNote with you, and tomorrow I will try to, yeah, I will try to do this. And if I can also talk about the logic gates, so logic gates will not take much that of a time, right? If I can talk about logic gates and also the dual nature or model. But this, but remember, you don't have to cover the whole syllabus. 8 questions, right? 8 questions you have to cover, and those would be enough. So those would be enough to get you into some good. Just remember this thing, right? Don't try to overextend or overdo the problems, right? So we'll stop here, guys, and see you guys tomorrow, right? So I'll share the one, right? I'll share the one. Allah Hafiz, guys. Allah Hafiz. Bye, bye, guys.
Thank you, sir.
Yes, bye, bye. Right.
Thank you, sir.